Hello everybody, welcome to another stream. How we doing? So last stream we added support for these things called temporary resources, and we completed it, but had a bit of a think, and the way we want to implement resizing, I think we'd better if we make some changes to the way we did temporary resources, just some slight changes, nothing too big. Yeah, so do some more temporary resources stuff today, and get started on actually doing some of the screen resize work, or the window resizing work. Hey there, Gloria, sir. How you doing? Welcome, sir. How have you been? So last stream we added. Hang on a minute. We added support for these things called we added support for like buffer initialized temp, texture initialized temp. So these are temporary resources. They have a lifetime at most of a frame, but you can allocate them anywhere in the frame and then deallocate them anywhere in the frame as well. And then when you sort of deallocate them is when you make a new temporary resource, it can alias the old memory, which is quite cool. My concern with this current API is that currently, where is it? Depth. Yes, when you start the frame, you can, where you record into the command buffer, you can just create these temporary resources. But the bad thing about this API is the fact that it returns a resource ID, which is very problematic, because it means that my UI API, for one, it takes in a resource ID when it comes to rendering images. And if we don't know what that is until we're actually rendering the frame, this thing that happens on the game thread is going to be a bit weird. We're going to have something else that comes in. So if they stayed fixed, at least it would be good. And we needed to fix something in the texture viewer, because the texture viewer needed a fixed ID, but I solved it by having this sort of texture info that gets made separately, and then the texture viewer now just uses this texture info. So what we're going to do is undo this, and after we've made it so the resource IDs stay the same. So we'll start off by making the resources the same. So I still think we'll have this initialized. We instantiate the temps. But you won't provide any dimensions. So you can say it's got a type, storage format, but the thing that actually controls the dimensions, these things are done later. Yeah, so we'll probably have explicit allocate functions, which will take in the size parameters and stuff like that. And that should allow us to create the temporary resources when we build up the game, but they won't be allocated. Then they'll get allocated throughout the frame, every frame. So I think that'll be a good solution. Yeah, I'm using Xlib and Win32, the Sully, because I've used SDL on that, but you know, whenever you build SDL, it takes ages to build. and I wanted to step down and learn more about what the operating systems actually do. I've done X11 in the past, but not Win32. And yeah, they're both really old, terrible APIs. But yeah, you know, the more you use the lower level stuff, you know, the more things that become possible. Because if you use some abstraction, it's, you know, there's no API that's perfect. But the platform one will have the most amount of features that you can do. So yeah, using just the lowest level API is typically a good idea. Otherwise, you'd just be restricted to whatever the abstraction decided to do. Texture views. Yeah, we'll go to texture views as well. The alias. I think we'll keep the alias ID there, but we'll right, sampler. Yeah, we don't allocate a sampler. Temp sampler doesn't make any sense. Okay. So the initialize doesn't take in any size information. Okay. Great. So these can only happen at boot. These happen during GPU frame start to GPU frame end. Or frame submit. Yeah. Didn't have much time to work on my RAM to VRAM transfer. I'll do that now. Awesome. That's really cool. Yeah, I still need to do something like that. Like an async loader. Yeah, whenever I need it. Yeah. Sounds pretty fun. I'm doing okay. I don't know. I was quite stressed today. I don't know. It's been like easily stressed out and angry today. So yeah, I've not been that good actually. But when I picked up my boy and saw that he was saying goodbye to his nan in the car and saying bye bye go, you know, it's quite cute. And it's the first time he's been doing it. But that really sort of, you know, put a smile on my face. So yeah, I'm feeling much better now, I guess. But yeah, also I've been working on sorting out something in HCC with my storage buffers. Sorry, storage textures. Currently my storage textures are done in a bit of a weird way, where you create like a storage format and a sample format and the memory gets aliased. It's a bit weird, not gonna lie. And in shaders, you have to sort of manually pack things down. So where's my sort of BVH ray tracer? Yeah, like the storage texture is like a I have to manually pack it down and swizzle it. And you know, whenever I do sort of rewrite texture, which is a storage texture, I say it's a U32. And that's because in Vulkan, I've said it's like a Um, yeah, I've said it's a U32, and I read it. I just read it as one U32, but really I manually pack in the 8 channels. Sorry, the 4 channels RGBA in there. It's quite funky. And then when I do have a sampler of the same texture, it just basically says it uses like a mutable format in the image view. So aliases the memory in a different way, which probably disables a bunch of optimizations, and it's a bit funky. So I've been working on, well, when I say a bunch of optimizations, I probably mean like, one or two. But I've been working on removing that and basically making it so you explicitly provide the format. So initially, the reason why I didn't do it this way is because you'd have to say like U32 times 4 and then put the format in that it is underneath. And I didn't like this because you'd have such a massive explosion in combinations. And when I have my sort of hard-coded functions to sort of load from a texture, it would be huge. But I've been putting a little bit of time in making it so that we can just provide in the format like this. And when you say unorm, or it's going to come out in the shader as a U32 times 4. So you don't really have to specify a return type anymore. And when you pass stuff in, it will just get converted down into that format correctly. And then I won't have to do this weird aliasing stuff anymore. And then it will respect the Vulkan spec as well, and have the correct image type. So it should be quite alright. So yeah, I've been putting that together. If I check my texture intrinsics, I've nearly got it working. I just need to, I've got 1 or 2 things in the compiler I've got to fix. But yeah, basically now you have these sort of load textures with a specific format, and it knows how to the correct return type. So this should be quite powerful. It means I won't have to pack stuff in the shaders. I think I have to like swizzle things at the moment. Oh. Yeah, I think I have to swizzle things at the moment in, which is the final one? It's the UI renderer, is it? Yeah, I have to swizzle the format to BGRA at the end and then pass it out. Yeah, so I then pack it down into U32. But ideally, I should be able to get rid of this now, and it should not have to care about it. So it should be quite powerful. So yeah, I'm looking forward to that change landing in the compiler. I see, so you combine 2 types into one, so there's the same amount of combinations, but it's more convenient. Yeah. There's actually more combinations because there's more formats. But there's more formats than there are intrinsic data types. Is that right? Is that true? No, there's less. No, there is less. Or is there more? I'm confused now. No, there's more. Because you've got unorm and sine norm. And then you've got these 1110s and that. Oh, did I mistype that one, I think? Yeah, I think there's slightly more. But yeah, that's it basically. But But yeah, so it should mean when I go back into my swap chain code, currently, so if we go to the backend texture initialize, this is the hacky stuff I had to do. So I've had this sort of storage format, which would be like a U32, and then a sample format, which would be 8888 RGBA, right? Or 888, you know, float or something. I don't know, just something like that. So you make your image, which will just use one of those formats, and then you create I have to create 2 image views, and I have to do a silly thing where I say, like, with the image, that the formats it could possibly be are these sample and storage format, and pass it in as a separate sort of create info onto the pnext chain. And I have to put a flag saying it's a mutable format, and this probably disables optimizations. Now the thing is when you create the swap chain, wait, before we get to the swap chain, and then afterwards you have to create 2 image views, 1 image view for the sample format and 1 for the storage format. So we have to get rid of this and just have 1 image view now. And then the problem is with my swap chain is I've had to create a fake swap chain, which is just another image that I rendered to, because I cannot create you don't create the swap chain image. When you create the swap chain, the display manager, whatever you call it, creates the image, and you can pass in the flags, I think. But not every device supports that mutable format thing. So yeah, with this change, I'll be able to literally write directly to the swap chain now and not have this stupid copy that happens at the end of the frame. So yeah, I'm happy that's going to be cleaned up soon. Hey there, Kraz, welcome. Oh, that's really great. You use HTC. Awesome. Fantastic. Yeah, it's pretty powerful stuff. Being able to share the code between CPU and GPU. What's your Helix theme? I don't even know. What is my theme? How do you do themes these days? Theme like this, isn't it? I think it's, what was it called? Nordic. Yeah, Nord Night or something like that. Nord Night. Yeah, just Nord Night. It's quite a common theme. DCMKDB drummer. No, I've not seen that drummer. But welcome to the stream. Right, so when we create these sort of temp ones now, texture init temp. Right. So I think what we'll do, we'll pass in 0. So E32 times 3, 0, 0, 0. So when you create the texture now, or the buffer, and it's temporary, we don't allocate any memory if it's a temp one. So these are surgeons actually. Assert resource init. And this was going to be called disallow resource init. So you only be able to initialize resources when you build up the game, because I don't really see any benefit at runtime being able to make new resources. Right, very good. So this is going to say GPU resource. So, well, all right, so in buffer init, we're going to call this function. Texture view. Right, so the thing you want to be careful about is if the lifetime is static, then we want to ensure that the size is actually set to something. So if lifetime right, for textures, so all the ones that come after the formats, so we've got dimensions, array layers, cool. Yes, these all get instantiated, so it allocates the object, the resource object, but not the actual texture on GPU. Yes, we've got to be careful. We shouldn't call init, we should only call that if it's static. Later on, we'll call the backend initialize. Cool. Yeah, that's quite good. And then yeah, maybe the alias. So for a texture view, you just want to be able to make a new texture view. What an alias is, you don't really care. What that is. Something like that. But when you actually allocate it, then we care about it. Cool. So let's take these now. I think we're in a good place there. Right, so these are the new functions. So it allows us to have the same ID between frames, which is going to be a big help, because we've been kind of relying on that with the UI, API, and also the texture viewer as well. It was also very dependent on having resource IDs that stayed the same. So we probably need to introduce another enum somewhere. GPU internal. So in here we need a new enum to probably just keep track of the allocated state. So you want to say that it's you want to know what is the this is such a long name. Memory state. Mem state maybe. Yeah, something short like that. So probably say mem state allocated. So the first one is going to be initialized probably. Allocated and then deallocated. So a static resource will only be set to allocated, but a temporary resource will be set to initialized. And then when you manually call allocated, be allocated. Then when you manually call tell it to be returned to the memory pool, it will be set to this state here. So I think that will help us with some assertions. Okay. So when we do these sort of create buffers and things, what we'll be able to do is say resource mem state equal GPU mem state initialized, but then if it's static, we'll set it to allocated. Right. We'll just do the same thing for the buffer. Sorry, for the texture. Like that. And then for the texture view. Oh, you didn't finish off the texture view, did we? Whoops. So, yeah, so if it's a temp resource, we don't want to do a lot of these checks. So all of this. Yeah. So it's all going to be zeroed, luckily enough. So we move all of this into its own section like here. That should be a big help. Right. Okay. Cool. So where's the other ones gone? Here they are. So this is when we now actually allocate a buffer and then allocate a texture. So we need to do a get resource. So GPU resource pointer, and we'll do a GPU resource get with a res ID. Then here we're got to put those assertions in. Right, be a bit of duplicate code, but it is okay. Not the end of the world. So we assert that the size is non-zero. Yeah. We then would like to actually set the things that we missed setting. just the buffer size, and then actually setting the mem state. And actually, there is one thing we do want to make sure that we are asserting that the lifetime is temporary, right? Can only allocate temp resources this way, right? You also have to call after frame. You have to call it after frame has started. Right, so this deallocated temp thing can now go. That's controlled by the mem state. Cool, so this looks pretty reasonable. Let's do the texture one now. So for the texture one, it's a similar thing, but instead it's with a texture. And then we want to make sure that we get the texture related stuff there. So you need all these assertions here. Like that. Resource type is cube or 6 layers. Yeah, not equal cube or 6 layers. Now we want to set the appropriate fields that we missed out on setting. So that would be these dims ones here. Then the mem state, and then actually allocate the resource in the back end. Pretty nice. Cool. So the final one is a texture view. So texture views just alias another resource. So I think it's going to end up... Oh, did I? Oh, does that say DR lock in there? Cool. So for the texture view... Right, so it was doing this where it did some checking. And then it will have... Alright. Let's get all this and we can condense it. Alright, let's just drop it in here. Wait. There we go. Cool, so we can drop that. It's gonna be made like that. It's already allocated, so we don't need to set all these. Base MIP and that, yes. And then these come from the alias to resource. And then back in it. Boom. Cool. That's looking quite alright. Right. They're in a pretty good place now. So now we've got this temp dealloc function, which ended up using this sort of is temp deallocate flag, which is now in some sort of mem state. So the resource mem state has to be equal to GPU mem state allocated, right? Temp resource maybe we say not equal to initialized temp resource has not been allocated yet. Cannot be deallocated as it has not been allocated yet. So we say not equal to deallocate as well, right? Cannot be deallocated more than once. Something like that. And then we set the mem state. Sorry, I got rid of this, right? Yeah, I did. Good. So then we set the mem state to be equal to GPU mem state deallocated, like that. Cool. And then we actually deallocate the memory in the back end. Right, so the next thing to do is to clean up the texture viewer code. Well, maybe let's write the usage code first quickly. So we've got that depth texture. Rather than when we're recording the command buffer, stuff, GP frame starts the command buffer, then we record into it. So we actually take this now and put it back into the initialization. So we put it right back in here somewhere, and you don't set any width of anything, right? There's no size information here. Right, this comes later. So what you do is you're creating the resource ID and the resource, but you're not creating it's not being allocated any GPU memory. So this function here, that we call like what it's called now. Temp texture alloc. So in that GPU frame start, we can then allocate our temporary resource here with whatever size we want. This could be completely made up at runtime as well. It doesn't have to be a constant. So we can have different size textures every frame, which we'll be moving over to hopefully this stream. Right, that's good. So now to spend a little bit of time. Did you try Vulkan HPP for resource management? No. Yeah, I wouldn't want to try anything PP for resource management, Yeah, it's just not really a good idea. I think people try and sell it as like a good practice, but it's really a pain in the butt doing it that way. So yeah, last stream we did some silly little thing which we're going to undo. This is rare thing to happen, but this is the way. So we added this texture info thing because a resource ID would change for a resource every frame. Now it doesn't. So this information will just be available. So I'm going to get rid of that name hash thing and just quickly go through and just yank it all out. So name hash now goes, we don't need that crap. Texture info now goes. These two functions now go. All right. Cool. Yeah, so it wants to be a GPU Right, that's cool. Well, if you're enjoying it, that's all you need, right? But yeah, it's like 100,000 lines of header bloat, which doesn't help you solve the problem. Like, yeah. But I think you will possibly not understand what I'm talking about. I'm gonna start trying to talk about it. Yeah, so this needs to be undone as well. Default from texture. Maybe dispatch copy initial. Interesting. Yeah, we'll keep this one. I added that in for the temporary resources, not because of this silly change with this texture info thing. Get rid of that. Get rid of that. Right, then in... Awesome. Right, where's the GPU.c? Crying out loud. Gimme, gimme, gimme. Here we go. Okay, so... Oh, too many things, apparently. Scroll right past it. So, just looking for all the silly changes. So, I see some silly things here, name hash. So we go around. Just get that out of there. Get rid of the texture info thing. It's a dumb idea. Oh crap. At the frame end, we've got to be careful how we go over and try and destroy all the temporary resources. We don't do that anymore. We'll have to do something similar. That resets them back to an initialized state. Right. So I go to that code. Right, texture view in it. Goodbye name hashes. Right, resource from name hash. Get rid of that crap. Goodbye. Cool. So now this is all that UI code. Oh no, UI code. This is after a command is ran. We check to see if the texture view is open and the one that you've selected is currently being recorded into the command buffer. Then if so, we dispatch a texture viewer copy and copy the resource to a temporary texture. Huh? I've got a resource ID. Whoops. Right, so the frame start is what I'm thinking about. We've got to iterate over all of the no, this code gets deleted. We don't do this texture viewer texture info anymore. Right, so I think I want to do that iterator. Is there an object pool iterator around? Where did I move it to in the end? I can just write one out, it's quite easy. So you make your resource ID, 0 initialize it, get your pointer to your resource that you want. Then you just do a while loop, object pool, iter next, GPU resource pool, the address to the ID. Let's go from the start of the pool way to the end of the pool. It will have to skip over any holes if there's any holes, but this one doesn't have any holes. I maybe shouldn't even need to use an object pool for this. It could have just worked with an array, to be honest. But I didn't know that at the start. Right, so all we need to say is if the lifetime is not equal to temp, we'll continue. Now here we're just going to say resource memory state is equal to memory state of initialized, right? So then when you do an allocate, it'll go to allocated. Then if you manually do deallocated, it'll may take it to the deallocated state. But we don't need to deallocate the memory manually on each one because this backend temp memory reset will go over all the heaps and get rid of all the blocks and reinitialize all the blocks which span all the heaps. So everything gets reinitialized back to empty, but it keeps the memory heaps around. Cool. So that's a lot better. What else? Maybe dispatch copy initial. Interesting. Yeah, this one. So when we do a sync resource, so this is when we actually try and use it in a shader or something. I want to make sure that it is allocated. Temp resource must be allocated if it is going to be used in a shader. So maybe we should do that sort of thing where we do this. We do two individual checks. Temp resource must be allocated has been deallocated and is now being used in a shader. You know, that could be a thing in the API where we can allow you to reinitialize the deallocated temp, but it just seems a bit weird. Yeah, it's a bad idea. Because the resource viewer probably will, or the text viewer probably will not like that. Right, so let's keep scrolling down, see if there's anything else that we need to change. There is a submit, I think. There's a bunch of commands. Where's the submit? It's frame style. Yeah, that makes sense to be in there. Where else did I put it? Ah, where else was that? Interesting. So it used to be here when you initialize the texture. Right, I need this code back. But I need this code. So it's in texture alloc. So if we look at the so when we allocate the right there, perfect. So when we've allocated the temporary texture, if I might have to put a barrier in there for it. If it's the one that's currently being viewed, and there's only the initial state is currently being viewed in the texture viewer, then do the copy. But it's just going to be a bit. Oh no, it does get synced as read only, but it's going to be uninitialized. It'll look weird. But, maybe we don't do that. Maybe we just do a clear screen at that point. But I don't know. Right. So the final adventure before we can get on to the screen resizing is correcting the UI code now. Here. So it's texture viewer UI. Okay. So I changed this to use that silly texture info stuff. So there's not much to change. And that name hash thing. So, right. So if you have a selected resource ID, so we're going back to this, which is just great. We get the resource, GPU resource, pointer resource, GPU resource get. This is so much better. Then we use the debug name here, and this goes in the tab at the top, and the tabs at the top. Then if you have one that's selected, display the actual contents of the texture viewer. So there'll be a left-hand side bar with all the information, and a right-hand side where you can zoom in on the actual texture. Yeah. Tab res ID not raw. Right. Okay. So this thing going to say we've clicked the back button to set the res ID to 0. Now, where we've got this sort of like info stuff, we replace that with resource. All these get replaced with resource texture dot. So this just displays all the information in the left panel, which is very useful. Cool. So after we've then displayed the left-hand panel, then the right-hand side box, which contains like the image that you drag around and zoom in and stuff. The else part is like we haven't got anything selected, so we need to do a list, right? And we changed this yesterday, made this loop, but we got to bring the old code back because it was just far superior way of doing it. All right. Thank you for history. What the crap is this complaining about? All right, say one of those warnings. Cool. No. Yes. Right, so all this is going to do is go over all the objects in the object pool. If it's a texture, so it's just basically filtering out textures that are not texture views and are not the texture viewer copy texture, the one that actually gets displayed, and filters based on the fuzzy search filter up here. And then we'll just below display a list. Actually display the list. So I've got to change that as well. Right. Oh, I didn't change that. Alright, so then we convert it back. Right, well, is that done? That's good. So then some of these functions got a bit changed a bit, which is weird. Okay, got that back. And then GPU resource ID. Okay. Right, maybe dispatch copy initial. So so if we have a tab which has a selected thing and it's selected the initial state, then do the copy. Cool. The dispatch copy code has also got to change. If there's not a tab that's open and selected, don't do a copy. Get the resource. Nice. And nice. Alright, it's got to restore this silly stuff here as well. These functions. Oh, for crying out loud. Cool. Right, nearly there in this file. I think that will be it as well, actually. Then we try and get it running again, and then move on to actually doing some screen resize stuff. Yeah, no longer do we need to create this stupid array. That name hash doesn't need to exist anymore. delete. Cool. I think we're there. Should we try and give it a go? So now we've made the change where resource IDs are persistent, even if they're temporary resources, and we manually have to call temp alloc on a resource if it's a temporary resource. And we've reverted our texture viewer changes. Since the resource IDs do not change anymore, we don't have to keep around that texture info. So it should be quite nice. Let's go ahead and give it a go. If a stream dies, I'll be right back, but it should be fine. Do I usually do like a sync first? Is that what I do? Okay, build and sync. Cool. Right, I got a bit of an error. Right, we're trying to do text resource get. Let's deallocate temp. Is that a problem? I don't know if that's a problem. That's all internal. I think that's fine. Right, Vulkan error. Memory back. Oh, it's got a null in there. Right, that's very interesting. If it's first frame, transition all textures from undefined to general. Ah, right, so maybe we need to do that for our texture resources and they won't show up in a very weird... Yeah. So, right. This is interesting. So, yeah, so if people don't know, you have image layouts. You generally have to transition things around. So if I'm going to try and use something in a shader, you can put, or if I'm going to read from a texture in a shader, you can put it in the shader read-only layout. If you're writing to, you put it in the general layout. If it's a color attachment, you put it in the color attachment layout. And this allows Vulkan to swizzle, or the driver basically to swizzle it in the configuration in memory where it's most optimal for that hardware. But they do have a nice way to simplify it with a general layout, just works everywhere for everything. But the assumption is that you will not get the best optimization. You'll probably get, it'll probably be like Morton swizzled or something like that. It will probably be swizzled in some kind, but it probably will not be in the most perfect layout. But I guess the implementation could just decide to do it in a very terrible way. But I imagine it is at least swizzled because when you write to a texture, it has to be from a shader, it has to be in the general layout. So basically you cannot use it when it's in the undefined layout. And I think so at the very first frame, we just transition it into the general layout, basically. Now I'm a little bit... Maybe we do transition it perfectly for transfers. I forget. Oh yeah, no, we just... Oh, what's this? Yeah, it's the swap chain. Ignore that. Yeah, it's just crappy swap chain thing, a swap chain again. Yeah, we just keep it in general the whole way. We never transition the layout. Even when we do copies, we never transition it. So when we do the backend init thing, what I probably want to do how do we know? Yeah, this is so we don't have to do any state tracking of like what was the image layout that it was in. But what we and just keep things very a lot more simple. So where's I used to have some functions which would check, I think, what did it used to be in, and then I might just put a pipeline barrier in, but then I have to do it per resource. It'll be a bit silly. You should batch them together. Oh. Yeah. You know what? Yeah, we'll... Yeah, it's a problem that we should solve. So where do we do pipeline barriers again? There's a general place. I think it's called a resource barrier. So we go over all the resources. But I think we have like copies and things, right? Yeah, but they'll use this barrier thing. Yeah, so maybe we can say like, if this is a temp resource and hasn't been used yet, the layout is actually... So how do we know this? Well, I think the sync state before state would be something... I think it'd be sync state before access mode. Yeah, if this is set, if it's been used before, then it's general. If not, just say it's undefined. And then that should... Yeah, it should be good. So I'll do the transition. So maybe we might be able to get rid of all that whole sort of code that transitions it all from undefined to general. I think we can get rid of all this because in the higher level code, we do our state tracking. We might be able to say no, but our state tracking is not persistent between frames. Wait, does it persist between frames? What happens to our sync state? Does it get cleared out every frame? It doesn't change every frame. Interesting. So that means the sync state will always be set after the first frame, right? So we should clear it for all the temp resources. So when we do that sort of frame submit, or the frame, yeah, submit. We need to take that resource index, get the sync state, and make sure we just set it all to nothing. So access mode is I read, write, all that sort of stuff. It can be quite basic because we only do compute. So we just clear it all out, and that should work. So could we, yeah. We'll give it a run, and then if it ends up working, we can log some stuff and figure out what actually goes on. Right, first frame we don't do the swap chain image. Oh, what the crap is this? Oh, this is in frame start, isn't it? How do we know it's the first frame? Oh, the Boolean then. Yes, the first frame we just upload stuff basically. And it's just a bit of a hack what we've got in there, to be honest. Right, temporary resource must be allocated before it can be used in a shader. Right. Oh, we didn't remove those GPU internal temp start index. Let's get rid of that. Right, so why in frame start is it then doing this? And ends up I'm confused why this even runs. Let's do a oh, because it would open two tabs. It would have been selected, and then it would have yeah. So it would open two tabs at the beginning, both for the screenshots, but it wouldn't actually be visible, right? So I think when we have this sort of selected tab thing, maybe we should say, maybe not. I can't return null because yeah, it's a problem. But yeah, I wonder. So we can always check if it is open. Basically, that's another way. But yeah, so it's saying that it's So it's equal to initialized. I reckon it's that screenshot one. But why is the screenshot one only initialized? Let's go to texture in it. See what's going on. Bit bizarre. Oh, the screenshot ones. Yeah, should be allocated. Maybe it's one of those built-in ones. So all those sort of built-in ones where I do it in a very silly way. So the surface one will just say it's allocated. The global buffer will say it's allocated as well here. Indirect args buffer, we just have one because it requires some special arguments. And then the texture copy, I think that's the problem. One of those. All right, we're back up and running. Awesome. So should we see if the texture viewer still works? All right, text viewer seems to be working. What about the temp resource? Here's the temp resource depth. Yo. Right, temp resource must be allocated before it can be used in shader. Right, did it in frame start? That's the problem. So effectively where we got this initial copy thing, this can only happen providing that if you get the currently selected resource and it is not a temporary resource, then you do it it's a bit fiddly. Ball GPU lifetime yeah, that's the lifetime we're looking for. Let's change it to this. And if it's not equal to the lifetime we're expecting, we'll simply just return. So you get the resource here. If resource lifetime is not equal to the lifetime that we're expecting, then we will return. That would be much better. So here it's expecting it to be a temporary resource. When we allocate a temporary resource, we go, we're currently selected this temporary resource in the texture viewer, and in the initial state, try and do the copy. This one, however, is looking for static ones. Right, so that shouldn't crash there. Texture viewer, depth, perfect. So this is the initial state. It isn't very valid looking, I know. Right, here's another. We should really put the lifetime in here. It would be useful to know what the lifetime is. But yeah, this looks alright. This is when we do the BVH ray traces, the depth map. Here's the 3D rendering, it just overwrites it. So basically, yeah, when we display those like properties, we simply just want to display the lifetime one. So we can actually do one of these like lovely short string things for the GPU resource lifetime. short strings. There's just two, right? Ah, I'm so glad this is much better now. Resource lifetime static would just be like static. And then temp would just be temp, right? Okay, so where we use those sort of short strings in those properties, man, this is so good. So lifetime GPU resource lifetime short strings, resource lifetime. Nice. So that'd be a lot better. Oh, the crap is going on here. No. Oh, that's in the public header. It's been moved to the internal header. Because that's where the this is where the lifetime state is. Right. Yes, and this is lifetime static here for these guys, but lifetime temp. There we go. Yeah, maybe this initial state should just be shouldn't be that. But let me just double check the those states because I'm interested. In Vulkan, right? When we do that sort of resource barrier, I want to see like. So we'll actually get the resource, we get the debug name. So whenever this is actually false, so we say if not of the before access mode, so if it's never been used before, this is the hope. We'll say first time, then put that in there. And so ideally you have on the first frame, all the static resources will get used for the first time. And then all of the then after that we should just see a repeat of the only temp resource being printed out. So I think that's what's going to be happening, and if so, that will be right. That seems like it's correct. So first frame, all these static textures would just get used, right? And then after anything, the single temp one. So now we don't have to. We removed that pipeline barrier, which would take it from the undefined layout to the general layout, and now just whenever it's first used, we track that, which is great. So that's really cool. Yeah, I'm happy about that. So yeah, I think actually like in that initial state, it's probably not getting transitioned into. Yeah, it's probably not getting transitioned into a into the right layout, hence why it's flickering all over the place. I think that's what's going on. Maybe. So if I go into gpu.c and then I would go to dispatch copy, which for the texture viewer. We'll put one of those programmatic breakpoints in where we go if resource. I think we do like a string compare. resource debug name, depth texture, because that's what it's called, right? We'll do one is called rate points. So we should hit that when we open it up in the texture viewer. So when we open this one in the texture viewer now, perfect. So now I should get to study if there is a pipeline barrier which goes in. So basically we put on the, okay, I just missed it. We put the sync code on it. Now we do a dispatch here, right? Now it goes over all the ones that are always synced. And then we'll emit a barrier. Now, what's in here? Resource debug name. Right, let's put B in there. So the texture viewer copy. Next. How many of these we got? Just one? Yeah. There's just the one. Right, looks like it doesn't get synced. So that means then, since it doesn't get synced, so when it does a read only on the sync resource, right, I think we want to say if it comes from an uninitialized state into something which is, and it's being used, then it needs to be synced on. So we do this logic. How do we guarantee that logic? So I think it's here. If it's writable or was previously writable, or we're profiling individual shaders, we put barriers down always. Yeah, so we also want to say if it was previously is undefined previous. Undefined texture. So you'd be like, if resource, GPU resource type is texture, and sync state before is access mode of none. So it hasn't been accessed before. So this is one of the new ones. So there's all of these guys together. Yeah. So that should hopefully fix that flickering bug, I think, in the texture viewer, because I think it wasn't being transitioned from that undefined state into a general state. So when we viewed it, it looked a bit weird. No, it's still a bugger. Can I put another breakpoint? Right, 15. Let's put another one of those in there and just check it this time. I forgot what happens here. Okay. So if we check the sync, gotta be careful. Right, so we sync as read only on the depth texture. So this is definitely the depth texture. There we go. And what we're saying is, hey, is it previously? Yeah, it is, right? So we'll go through here. What's this doing? Oh. Yeah, no overlap, basically. Right, it pushes on there to be synced on the next one. Okay, that seems correct. Yeah. Okay, that seems correct. I don't know why it's flickering then. It doesn't matter though. It's not the end of the world. Oh yeah, Kraz, remember you got another error for me I should look at. Probably should do that in a sec. Is this Vulkan error message related to resizing? Present info, wait 74's queue is waiting on a binary 74 that has an associated signal, but it depends on the timeline semaphore wait. It does not have resolving signal submitted yet. Interesting. Yeah, I think that is to do with that might be the first frame. Yeah, effectively, right, what it is you've made, I think what it's saying is you've made a command buffer and you haven't said at the end of your command buffer, signal the present, right? And the present is waiting for the signal, but it will never go. And I think that's what it's tracking basically. So I think when we do that submit, yeah, I think on the first frame when we do a submit, oh no, it should always be saying present and empty present. Is that right? Yeah, I don't know. Yeah, I think it signals the semaphore. Yeah, I don't know. I think I got a bug somewhere. That's the point. I should really turn on these validation errors and track these down. But yeah, you did mention something like a week or two ago now, which would be helpful. Oh, it's right here. Good. Right, the window move. That is wrong. Right, it's marked as resized. That would be funny. Right, thank you for that. Copy paste error. So when you move, it'll be like, hey, it's resized. Yeah, maybe we should enable those Vulkan validation errors because although I did think they were kind of running just then. So I don't know. Oh, sorry, this is when it spams out all that. So debug, this is the dump, but I've always got the validation on. Yep. So I've got validation on always. Cool. Right, it seems okay at the moment. Right, so let's get started on some of the screen resizing stuff. Now I've got this temp resource stuff. So we're going to start with the color picker. So what the color picker does, and it's a bit silly because I didn't have a way to create these resources of different sizes. So you see this sort of render here and this render here. They're a texture that get rendered every frame, and to the color picker plane. So it's a screen, it's the resolution of the window, and we just render into, I think it's the bottom left. We will render based on the size of the color picker at that time, right? And now we're going to make it so that it's only allocated. It'll probably be allocated every frame still, but it will get rendered to. Yeah, allocate every frame, but only be the size that it needs to be. And the plane is also the same one, but it's a 1D texture. It's just a strip. Because that's all it needs to be, is one-dimensional, this side panel. Cool. So all we're going to do is, like last stream when we looked into it, it was a hassle because our resource IDs changed. But now they don't. So what we do is we still... And hey there, Captain Chica, how are you doing, sir? Welcome. How you doing? So we still instantiate them like this at the beginning, but they'll be instantiated with the temp side of things. We'll get back to that. And then when we start a frame, we'll do temp alloc. Actually, color picker. Okay, so we instantiate a new temp resource when we build up the game, and we'll simply just get rid of all the size parameters because they are not needed anymore when you boot up the game for temporary resources. And then every frame, when we record into the command buffer, we simply just allocate them. They're called something like GPU temp texture allocate, like that. And we can pass in a dedicated width. So we take this here, we'll call it the color picker dims. Color picker dims.x. Right, so that's only being set to the width at runtime based on what the color picker actually is. So it'll be at least 1 pixel because we have one, and then we oh no, I haven't tried resizing yet, Akraz. Yeah, we've not got all the code in yet for that, so I don't want to resize it because it could crash the stream, I think. When I think I've got it done, I want to do the resizing though, obviously. I remember finding more validation errors. Oh yeah, I remember that. That's something I wanted to do. Yeah, whenever I next do a bunch of rendering, I guess I'm doing rendering now, to be honest. Yeah, there's that configurator, isn't it? Yeah, there's a JSON file basically. I think if I get the SDK extra stuff from the repo, I'll be able to toggle it on with some UI. But yeah, you added stuff like some extra checks. I remember. I think there was a threading one that you did or something like that. Yeah, I should do that. Because I am... Oh no, it's like a synchronization one. Or something. Yeah, because I'm getting one sort of problem where my performance, when it gets, I think, when it gets to about 120 FPS or slower, it really starts to spike in the performance for some reason. So I don't know what. Maybe that's just to do with engine profiling. I got something dodgy going on there. But I was thinking maybe that could be... It could help that problem. Yeah. Yeah, so I think this is alright. Let's go into the editor. Not much of an editor, but there is the bare bones. We've got like a gizmo in that now. We're going to be working on the material editor very soon after the resize stuff. I got the encoder system ready to go full ham. Make a material file. Make an editor for it. It'd be pretty nice. Here's a little button. It's a grey button because it's a grey color picker. Click it. This renders alright, doesn't it? Right, so open up that texture viewer. Oh, I can't do anything. Shoot. Well, this sucks. Hang on a minute. I gotta do a special thing. Show color picker. Good old XOR. Cool, so I press the Y key. Right, so if I click it, opens that up. I can close it. Yeah, we can have the texture. Right, here it is. That size, isn't that great? So that's the resolution apparently. Yeah, then I'd press the F, was it? No, it's the Y key, isn't it? Out comes this. Oh yeah. Temp resources. Cool. What is what's next on the agenda? So we've got to try and get all those fixed. So in game.h I think it is, or I think it's in some other thing. Oh, it's in game.h. Yeah, we've got these lovelies. Temp display width and temp display height. And I think these max ones can stay. But ideally we want to get rid of all of these. And they're just in tons of places. Well, okay, probably around 10 places. Some are going to be easy, some are going to be a little bit more tricky. But I think we should be... So let's look at the operating system. So apparently we just open up a window of a fixed width for some reason. So yeah, we don't really have a multi-window thing, but I've split it up into an open window. This is only a request. The operating system doesn't actually have to respect that. So I wonder... what are some valid values? So yeah, I wonder, right, if we could have. Is there a way to say where you don't care about the window size and it just does the default? But I guess you're better off getting the sort of actual size of the window, size of the display, as you know, something like this, and then selecting like half the resolution or something. I don't know, and just opening up a window. I have in the past done the API where you can get the displays and iterate over them and that. With X11. But I don't think I've got it in this code base. So maybe we can just say X11 get root window size. This music is a bit too try hard now. Yeah, so I could get these sort of like properties here, right? And then we'll just so let's just root attributes. There is a status thing. Right, get to the display. OS backend connection. So a display is like a connection to the X11 server. It doesn't actually mean a display. The window, so we want to use the root window. For the default screen. And then you get back some status. I have no idea what the return is. A bad windows, it bad, whatever. We'll have the width and height in here, so we'll look at that. What is the status? If a function fails, it will return 0. Sounds like a Boolean. Sounds like a status, not gonna lie. Yeah, I guess it's just a 0. Yeah, I guess you can just put in an if statement. But yeah, so print display. Let's do the width height thing like this. Let's just do that, see what happens. And then we can maybe make this a function or something. So root attributes width, root attributes height. Yeah. So we'll put a nice little exit here as well. So we'll just see it boot up and see what it gets us. All right. I missed the root attributes here. So we can make it a function, say, hey, get us, there you go, 1920, 1080. So if we just take, if I just have another operating system function, say, get us the size of the default monitor, we can just do this, and then that gets passed down, maybe. Like, essentially, we'll probably have some configuration file where we store the resolution, but the one we default to, it might be in windowed mode. I'm not sure we'll do it at half of those resolutions. So I think that's the way we'll roll there. So operating system .h. So there'll be a way to do a where's something that's very OS Linux. Yeah, I guess some of the functions are actually implemented directly in here, aren't they? They don't have to have backend on it. Yeah, like the virtual memory ones are just in it. Yeah. So I think the way we'll roll right, stuff to do with a window. So you get the bottom left position. So I think we'll have another one for display then, and you'll just be able to get the OS display dims. So we'll just get the main display dims like that. So in OS Linux, somewhere around the window, I don't know where I can stick it, to be honest. Here we go. We can just implement this with that attributes thing. X get window attributes, yeah. Right, so you get the backend thing, backend pointer. Where's your default screen? So by default, I guess we'll just pump out, I don't know, 720p, all right? All right, so by default, we'll pump out this, but then if it errors, we'll pump out 720p. Return shouldn't fail, right? There you go. So now I've got this lovely function. Soon we should be able to remove this temp display thing. When we've got it already, we can give it a go. by passing it down from the directly into the OS backend initialize function, which would be cool. And then later on, that'll probably come from some configuration file. I remember putting a hair out trying to figure out how to create a window that covers the full screen with Win32, but I figured it out. Oh. yeah, you've got you got to try and like. There's different ways of doing it, isn't there? You can do it. I've never done it, but I've heard there's ways of like if you did it in full screen mode, like proper full screen mode, you can't like Alt Tab out. So sometimes, but then like I think the preferred way of doing it is making it a full screen borderless window. But then like if you do it that way, the composite is still running or something like this. So there's a little trick you can do to sort of disable the compositor, but it also be a borderless window, I think. Yeah, I think there's some of that I've heard about people saying. So yeah, whenever I do full screen, it's probably going to be a whole pain in the butt trying to figure out those different full screen modes. I remember doing it for X11 and that was tricky. Because with X11, you've got to like remember what the previous state was and then restore it back. And if you don't, you can mess up the whole desktop environment. So you really got to be nice if your program crashes as well. It's just it's weird. Like X11 allows you to literally change the whole configuration of the machine and it won't put it back. It's exclusive full screen is trash in Windows, so you don't even want to support it. Borders full screen, that's it, isn't it? That's cool. Yeah, I think that's the one I heard about. Rightio. So let's take a little bit more of a gander. This is in the Windows side of things. Yeah. Let's implement that function on Windows. Alright, let's see how easy this is. Win32 get display size. Get system metrics. Obviously I only want the default one. Right, XY screen. Get device caps. Nowadays I've seen these functions before. Right, I've not used that system metrics one before. CX screen. Of the primary monitor, this is what we want. Easy peasy. CX screen. Oh, it's SMCX screen. Now, what could this return? Right, so obtained using device caps. But it seems like it always returns something. If function fails, the return value is 0. Right. So if it's 0, so if that succeeds, we return something like that. And then if it fails, we'll just return 720p or something. Right. Cool. So yeah, in the future we'll when we've got the rest of the renderer to support resizing, we'll finish it off by getting this display dims and picking a reasonable size for the window. Right, so the next one to search for is the temp display width again. This resolution you can pass to backend in it. Is it the client area or the whole window area? Yeah, so X11, when you create the window, it wants the client area. It's without the border. I'm not sure about Windows. What does Windows do? Is it called create window? Classic. Does it do? Oh, Windows wants the Windows area. Damn it. Hmm. Well, that's a bugger. Why are these things inconsistent? Yeah, maybe it doesn't matter so much because we might just be able to remember it in the configuration file. But maybe maybe it does matter. Yeah, that's a bugger. Because yeah. What will we do then? Yeah, we just have to be careful when we get the size of the window. We have to make sure when we save that to the configuration file, when we have one. Because if not, it will just we got to be careful of that border. Because if not, every time we save that to the config file, it'll just keep shrinking basically, or growing. I forget which way around it would be. Hmm. Right, what's next? So we've got these screenshots. Yeah, the screenshots should probably be allocated to the temporary. Damn it. So we get a screenshot. So when I take the screenshot, it'll be the size of the current window. But then I use these to display inside the UI, is that right? Or the texture viewer. So we'll get copied from and then displayed onto that texture viewer thing. So I think we can get away with the maximum resolution. Was in game.h. Max display width. So we do something like that. I think that'd be pretty reasonable. The maximum size is like 4K basically. And then that will, it should be alright. Right, let's keep going. Temp display. This is the texture viewer saying, hey, load it in at this specific thing, but I think we get away with a smaller resolution there, so this assert doesn't need to be here anymore. Well, the assert would just be like, we'll catch the assert in the upload code anyway. Cool, what is this? Oh, this is the debug rendering code for the BVH stuff. We won't need this anymore. Let's simplify this and get rid of it. Alright, let's get rid of this debug draw stuff. No draw as well. Window, and if it's broken, you just need to adjust. You need to adjust in other calls, damn it. So much debug code, what's going on? Oh, there's the PBR stuff as well. We don't need that anymore, we're building the viewer. Right, so seems to be some secret sauce here. How do you switch the window between normal and full screen? Ooh, interesting. The L button up. Let's drop down those windows. Thank you so much. Yeah, it's the proper full screen. I know you wouldn't give me that one. Yeah, the borderless one. Amazing, thank you, thank you. Alright, right, more temp. Display size. Right, so for the depth texture. So for the depth texture we've got right, where are we gonna get so the surface I got it. So whenever we do this here, we want to get the surface dims. So that will be by doing a resource or a texture dims dim Yeah, texture dims too. Dim 2. GPU surface resource ID. So when we do frame start, it's going to check to make sure there is a surface that we can render to. Then we it'll create the right size and everything. And here asking for the dimensions of that. So then all it should be is we just pass it in when we do these temp allocs, and they should be the right size then. Be pretty nice. So UI tile dims, right? This is where we have based on the screen resolution. So many tiles that we have. So we do a tile-based renderer for the UI. So we should just be able to use the surface dims X. So we've got chunks and tiles. Chunks are just bigger than tiles. So tiles are inside chunks and pixels are inside tiles. That's all it is. Nice. Then this is the globals. So these are passed. We have a globals buffer where we just store a bunch of global variables, basically accessible to every single shader right out the gate. So we can just do a special macro with the name of the global and just access it, read or write, basically. So yeah, we could do a surface dims.x, or we could just do surface dims.xy. They are unions, so they can do that. Right, this PBRV mode. Let's just do 0. Right, some more temp display whips. Half screen resolution. Div divide by a scalar. Nice. A floating point version. Then the half dims of a floating point version. Yeah, we don't want half a pixel, so I'm going to do as integers first. Cool. How we're looking? So clearing the screen. We just want to use the surface dims for that. Right, there's quite a lot of these. So, oh no, there's only a few. So that was the BBS ray tracer. This is the 3D render, and then this is the 2D render. It's not that big. And then the UI render, which goes last. All right. Awesome. What are we doing next? So That's all the ones inside the graphics file, but let's see if there's anything. There's definitely more dot about. So very close now. Right, so when we create the surface, it is hard-coded to that temp display width. So if we set it to 1, 1, right, just one pixel, when you initialize the GPU system. Now I want to be careful because it actually has to get updated. So in frame start, we call into the back end and we get it to acquire the new swap chain image and all this, right? So I wonder if we surface resource. Yeah, I don't think we're doing anything here. So basically, swap chain dims. All right, here's what we're gonna do. So where we set this, we're gonna go surface resource. And I don't know where this is actually created. Did I misspell resource? No, I didn't. All right, here we go. So we'll say dims is equal to ggp Vulkan dims xy. Oh yeah. Right. Or it's texture dims. So now we definitely know they've been updated. Yeah, I didn't update them. Cool. Maybe we'll move it down here. Nice. Rightio. So let's look around for some more of those temp display things. Right, so the Windows and Linux ones, we're going to get back to those, but we've got a thing ready. Then there's editor. So the editor, right. So we get the window. Window dims, OS window dims. So we should be able to get away with that. And this will be able to do our gizmo. So I already got this. I got this available still, so we should be able to bring it up whenever we do the window resize and see if that still works. Okay, so we're nearly there by the looks of things. Yeah. Right, in main, when you start the UI frame, you give it the window size. And then that's it. Right, so my concern is we do a bunch of events. Clear the draw storage. Yeah, so we should do all the event processing and then start the UI. And then in here we can do a cast of window size or dims audio. All right, nearly there. So now all we need to do is get rid of these constants. The max ones are going to stay. They are still useful. I don't know how many places are actually using these. With the UI tiles, tile capacity. Right, yeah. So we allocate a buffer filled with tiles, so they need to be the maximum window size. Well, technically we've got the temporary resources now, so we don't need to do that. Let's put a to-do down on that. Yeah, but I can't be asked to do it, right? We don't need to. What else? Yeah, the screenshots, they're okay. Those need to be persistent. And they're only for debug really anyway. Oh, this is Helix. It's basically a, it's like Vim, where it's in a terminal, but it comes built in with an LSP. And, you know, it uses a configuration file rather than a programming language. So it's quite easy to configure. And it comes built in with a lot of stuff. Lazy Vim. I heard about Lazy Vim. Or was it Lazy Git? Maybe I'm confusing it with that. But yeah, Vim is I've used Vim. I actually rage quit from it because NeoVim broke and I had a config and I didn't want to maintain it anymore. So I was in a search for something more simple and elegant. AO3GL, how's it going? Welcome. Right, so I think we're in a good place. I just got to change those temp display widths in the OS Linux and Windows by passing the display size down. So I'm just going to take a quick little break and then we'll come and do that and then test it all out and hopefully we'll have the whole screen resize working. Right, so BRB. All right, welcome back, everyone. Have you got time to talk about projects? I'm doing cloud gaming. I don't know. I'm not really like a fan of cloud stuff, to be fair. I'm more into like the low level system stuff, not really into web technologies. So yeah, it's not really a type of conversation I'll be interested in, really. Yeah, so OS, Linux and things like this. So effectively what I imagine is with OS init. So OS initialization we'll call backend init, right? So the way I imagine it is like, so we'll load some settings up and the settings will have the window size and you will then pass that down. So I don't have that settings file yet, but we can easily make one now. I've got the encoder system. But we're just going to do the very simple thing. So I think what we'd like to do is create some kind. I've got to be careful. OS spec or something like this, and this is what you pass to. So we want to go like, just, you know, pass in these sort of initial window dims. You know, I'm doing a structure because you probably want to change it, and you always have to change like a million prototypes and stuff like this. So it's just a lot easier to work with. All right, so it's got passed around. So we'll go OS spec window dims. Now we haven't initialized the backend yet. This is a problem. So we probably want to make the window a separate call, actually. So maybe we'll just undo all of that. Yeah. Sounds sensible. All right, back to the drawing board. So basically in the back end in it, I think what we need is a window in it instead. So, or a window open. And you can only call it once. Yeah, we'll pass in the dims. Right, like that, something like that. Be alright. Windows window open. C# Uni Unreal. Nah, I'm not interested in that stuff. It's all kind of, you know, assuming people doing it. That's the problem. It's also just more complicated than it needs to be. Yeah, it's alright, innit? That'll do it. So I open up the window. Where's our Windows window open? So we get rid of that. Crap, what is all this crap? But do you need the window to further initialize the backend? Wait a minute, where do I get the window size again? I need the display connection in X11. Oh, this is just a bugger. We might just have it pass. But then on Windows, you don't need anything yet. Well, I guess there's ways to do it on Linux, right, without the X11 system, but that's besides the point. Yeah, because I think this all works off having the Windows. Yeah, the HWND. Right, so I think what we're going to do is we'll just do it all in the back end. So we'll just say something like display dims and we'll just be something like OS divide scalar display dims 2. So, all right, to do make this display or this window size come from a config file and be done in a cross-platform, in a platform agnostic way, or outside the OS backend code. Yeah, let's do that. So if we go to Linux now, or we create the Linux window, Linux window open, something like that. Yeah. So actually, I think in the yeah, this needs to do a .x.y type thing. All right. Nice. So I think that's it. I think we're ready to test out the screen resizing. So fingers crossed. What is this? Shoot. Should we just memset the crap out of this? Oh, let's get rid of the model tree test. That'll do it. Oh, doesn't that look good? So that's a smaller window than we're used to. So move it around. All right. So as Akraz mentioned earlier, we do get a bit of a a problem that goes on with the validation layers when you resize. So, although this one might be a bit different. Right, so this is probably to do with that swap chain image. Probably throw a pipeline barrier down. Yeah, maybe that. Yeah, I think this is because I removed the pipeline barrier code that put it into a general state. No, but that was on the first frame. And it only did it on the first frame. Yeah, I don't know then. But yeah, I got ways we can fix this. Basically, if it's been resized, we clear the sync state. So you'll just be like, you do something like GPU resource sync state. You get that before. Sorry, you index it with. Yeah, you index it with the resource ID. Index part of it. So this would be the surface resource, and we just clear out those before access mode to say it's never been accessed before, and then the barrier code would be like, oh, so that's in the undefined layout, so when we next use it, it will transition it to general. So that should... Oh, what the crap is going on here? Right, something clearly buggered up. Right, I think I just deleted a whole bunch of code accidentally. Right, I did something there sneakily. I already went to the root and I did something. Alright, put that in now. Yeah, I went to the top of the file and probably deleted a line. Let's try that. Oh my days. It works. Finally. Look at that. It's a bit jumpy though still, but I'm happy with that. Lovely. So here's the depth texture. And as we resize it, look at that. Lovely. Yeah, I removed all of those temp displays. They're all gone now. They're all gone. Oh, those screenshots are being loaded in a very funny way though. They're broken. Wait a minute. Yeah, they're a 4K resolution. Alright. It's like find the initialized memory. Right. So that's a bit of a problem. Because that's not the point of the screenshot viewer. Well, if you're viewing a particular screenshot, maybe if you upload it every frame. that you're viewing it. No, but the whole point of the screenshot texture is that you can take the screenshot and then save it out. Like read it back, save it to disk, and then it's got a secondary purpose where you can actually, yeah, it's got a secondary purpose where you can view it in the texture viewer. So maybe we need to have 3 textures. One is where you just take it, read it back, and it only triggers it on the frame where you press the button. These two will load in the previously taken screenshot and only be the resolution that the screenshot is. Or we could just override the dims. I might just do that. I could just override the dims somehow. So say if I take a screenshot now, what happens? Okay. Yeah. Maybe we need to rework this thing. So what we're going to do is, oh. Right, I'm happy that that worked out then. But I don't know why we didn't get that error. We should look into those extra tools maybe. Right, that's reinstalling, so it's not that. I've already got that. I've probably got a lot of this stuff that matters. There's devel for developer. SpearV tools, utility libraries, HTML docs. And they're all gonna be reinstalled, is that right? Yeah, so I've already got them. Well, not the HTML docs and the utility libraries. Yeah, I don't need those though. So that's not the problem. Can you get the Vulkan configurator on Linux? If not, we have to edit a JSON file. It says it's on Linux. So delivered in the Vulkan SDK. VK config. Ah. Nice. We're in. So let's enable some extra bells and whistles. So overriding layers. Yeah. So validation, all those boys and girls, areas, let's tick synchronization on. Mid time validation. Takes into account memory accesses performed by the shader based on Spivey static analysis. Warning can produce false positives. Right. Rightio, let's give this one a go. So, let's launch the game now with validation layers, see what goes on. Alright. Right, straight away, read after write. Clear color image. Right, copy, hazard, read after write for source image, blah blah blah. I think we should have got those debug names in there. It should have showed up, but maybe I've... Yeah, I don't know. Access info, sync, copy, transfer, read. Prior usage, clear, transfer, write. Okay. That might have been the swap chain. Yeah, I think that's the swap chain. It's in graphics in it. You see, this is the problem. So like, the first frame we technically don't need to present. So I think we need to say, yeah, we don't really need to present on the first frame. This is the issue. So maybe we put the present in a different, yeah, but I don't know if it's going to be platform agnostic if we do it that way. So in a submit, I was thinking we could break this apart a bit, but you can't. Yeah, so we'll have something where we know it's the first frame, and then we'll just basically don't do the present, and I think that will stop the problem. When it's related to the key present, and you have older drivers, I updated my system somewhat recently, probably about 2 or 3 weeks ago. So I don't know if there's a newer validation layer, because it's the validation layers, which is the strange thing, right? Yeah, I don't know. This would be the configurator, wouldn't it? Yeah, I don't know. That's the representative of what the... Well, yeah, you do like a VK layers or... Ah, screw it, I don't know. Yeah, you can get the layer version or something. But yeah, I'm not sure. There might be a newer one out. I'll probably update it at the weekend or something if I've got time. What am I looking for? So in GPU internal, I think we'll just do a silly boolean. Well, this is it, right? Disallow. So we want to say, no, it's slightly different. Is first frame. So in GPU.c and submit, we'll literally just throw a boolean down, edit the boolean and set it to false. When you initialize the GPU system, we'll set it to true. Then inside the backend, there is this thing called isFirstFrame. We can just do now GPU dot. Yeah, I didn't want to add the swap chain image to the barriers. Right, so where's some swap chain related stuff? So if it's not first frame, I'm really not a fan of having to do this boolean check every time, but I don't know, should be alright. So if it's not the first frame, don't bother requiring the next swap chain image. Don't bother doing the image barrier for it. What is this code? Is this the submit or something? Yes, yeah, so in the submit. Where is it? Swap chain image and another swap chain image. So don't do the image barriers. So if GPU you want to put 0 in there, if not do the image barriers, yeah. And then we basically don't do the present stuff as well. Wait, what is this? If first frame. Oh, we didn't do this at all. And then in the frame submit, here's that copy that was probably the problem. So we've got this silly like fake swap chain thing at the moment because the way my shader compiler works, but literally in the process of fixing that off stream so I don't have to have an extra copy of a swap chain dot about, and it'll just simplify other things as well. So what is this doing? A copy, then it transitions it to present. So we say if not GPU is first frame. Yeah. So this, wait, we're saying, let me just double check. Because the validation error was saying prior usage transfer right. Here's a transfer right. This could be incorrect. Destination stage, none for present. Oh, prior usage was a clear. Oh, so we didn't put a barrier in it before the copy. Right, I see. Right, that's pretty easy to fix. Yeah, what you need to do is put another barrier in, basically. We won't need to do this copy soon anyway, so this will just go, but let's just get it correct. So you need to say that it was doing, there's a way to do this. Wait, doesn't the swap chain image need to reset the state every time? Probably needs to reset the sync state every time. I don't know. Transfer. Right, yeah, so this source stage mask stuff. We need these guys. Alright. So your sync state will be based on that GPU surface. Alright. Okay. So before it's being used in this way. Now it's going to be used as a copy or a transfer, isn't it? VK stage copy, and then the access VK access to transfer right, and it's going from the general layout and stays in the general layout. And resets the swap chain image. So that should be the fix to that validation error. So let's give that a launch. See what happens now. No. Oh, I think this is the one that, yeah, this is the one that Acros came up with. Interesting. So this is still the first frame because it's doing GFX in it, right? So I think it is that problem that I said where it's the first frame. We're doing a present on the first frame when we shouldn't be doing a present. Yeah. So that's because the first command buffer is purely used just to set everything up. It run, uploads, run some compute shaders if we need to. So I just missed doing this. So we're in the submit right now. This is ifed out for doing the copy to the proper swap chain, which will get removed. We're in the command buffer recording. Now we've got to be careful. We should split the command buffer so the first write chain is at the start of a command buffer. Yeah, that would be quite nice. So effectively, what this comment is saying is we shouldn't wait on the whole command buffer before we can start running the command buffer. The command buffer can start running as soon as the previous command buffer is finished. But we should be able to wait. We should be able to wait right when we're about to write to the swap chain. And that should give us that should be a lot nicer for performance, basically. Rather than waiting for your whole frame's command buffer and just waiting until we can write to the swap chain and not even just wasting time, basically. But anywho, I think what we need to do, so there's a wait semaphore. Is it talking about the wait semaphore? Yeah, it's talking about the wait. So, regarding the wait, GPU is first frame 1, if not the rest. Anything else to do with the swap chains going on here? Right, signal semaphore, signal that ready to present. So that's another one of these guys. All right. And then this present here is another one of these guys. If it's not the first frame, then present. Cool, let's give that a go. Oh no. So it seemed to run... Oh no, it didn't. Oh, the semaphore count is different than the... Ew. What is this? Wait semaphore is a timer semaphore. P next. Timeline semaphore submit info. Right. Some more spaghetti. Thank you, Vulkan. Right, next error. So this is when we actually try and render a frame. It's done initialization, rendering the first frame. Right, access info, prior usage present. Right, something to do with the swap chain, how then it acquires the next image or something like this. Yeah, we'll look into that. Right. Okay, so let's say we turn off the validation layers. Does it still run? Alright, it's good. Cool. So it's got window resizing working today. What I'm going to do is commit this code, and next stream we might just quickly tackle these errors because it'd be nice to get it working. What was the next thing I wanted to work on? What was it I wanted to work on next? Ah, yes. That was it. So, because we're building an editor, we want to be able to have a piece of UI on the screen, and then in a sort of smaller window here, we want to be able to display the scene, right? And have like a sort of editor UI basically. So Yeah, I think what we want to be able to do is render out our scene to a texture, which can then get referenced in the UI. And yeah, and we have the mouse position stuff all sorted out because we have some debug mouse position stuff where if you hover over the mouse over the scene, it has a mouse coordinate basically. So we want to make sure we have the correct mouse position relative from the bottom left of the scene image. So stuff's to do like that basically. But yeah, I think we're going to be getting the housing together for the UI for the material editor. We can edit some basic properties of a material. So yeah, that's what we'll get started on next stream. So that'll be on Thursday at 7:30 p.m. GMT. There's a Discord if you want to come and hang out. In the meantime, I'll drop a link for that. And yeah, that's all I kind of want to share for now. But yeah, thank you for coming, guys. Good to see you all. We finally have screen resizing. Finally. It's like a real game now. Real game. Alright, maybe I can raid Tim. But we could raid Artie though. Yeah, let's raid Artie. I think he's got quite a cool game coming on. It's great seeing it. Right, cool guys. Yeah, have a good Wednesday. Hopefully see you all Thursday, if not Sunday. Right, catch you later. Bye bye.